A washing machine is operated by a microcontroller. The drum and motor is connected in pin 7, and a common programming technique is used to control the drum motor speed. Complete the initialization for the PBasic program with reference to comments and the data booklet. So your data booklet will give you some clues for answering this question. Okay. Right, so we're going to set up 4 7 as outputs and the rest as inputs. The command to do that is let dir. Let dir sets the data direction register. Okay, to set an output, you put in a 1. Right. So if we let dir and then the percent symbol to tell the computer the next command coming is in basic. So it's let dir equals percent 1 1 1 1 and then 4 zeros. Okay. This one here is defining the counter address as B0. So this is a symbol counter equals B0. So that just renames B0 as counter. Okay. Complete the PBasic sequence to control the motor's speed with reference to comments and the data booklet. So our clues are down here. Okay, so we've got a set a for next loop to 200. So for counter equals 1 TO 200. Okay, and then this is the end of the loop here, so this one here will be next counter. So it's for counter equals 1 to 200, next counter. Switch on the drum motor stuck in pin 7. So you can either use high 7 or you can use let pins equal percent 1 and then 7 zeros. A 5 millisecond delay, so that the command is pause, and to get 5 milliseconds it's 5. Okay, if it was 5 seconds it would be pause 5000. Switch off drum motor, you can either say low 7 or you can say let pins equals 0. They'll both switch off the motor. Name the full name of the technique used to control the motor speed in the program above. It's called pulse width modulation. Pulse width modulation. Okay, so describe with the aid of a sketch how this technique is used to control the speed of a motor. So the sketch, the pulse width modulation depends on switching on and off the motor. So the on time is called the mark and the off time is called the space. So if the ratio of the mark to space is big, the motor will be going faster, and if it's on for a short time and off for a longer time, then the motor will be going slower. A 10-pin bowling alley uses a mechanical system to return the bowling balls. Okay, so the balls are again lifted back up by this belt. Okay, it's a tooth belt. The tooth belt helps raise the bowling balls to the bowling station. State an advantage for using a tooth belt over a flat belt. Okay, a flat belt might slip. Another type of suitable belt, a V belt. Okay, that will also have an increased surface area, so it's less likely to slip too. Suggest a reason why pulley A is the driver in the belt system. Okay, this one here is the driver. Well, it's to keep the top bit in tension. If this one was the driver, we'd be trying to push the belt up the hill. This one's pulling it up the hill. It works better like that. Okay. Calculate potential energy when an 8 kilogram bowl is raised to a height of 1.47. In tech, gravity is 9.81, so potential energy EP equals mgh. There's your m, the g is 9.81, that's in your data booklet, and the h is 1.47 meters. The motorized chain drive is used to drive the belt. Okay, so there's a diagram there. Selected motor is going 400 revs per minute. There's 35 teeth on the motor, 125 on the output. So the driver's got 35 teeth and the output thing's got 125. Calculate the velocity ratio of the chain drive system. Okay, so it's driver over driven, so it's 35 divided by 125. Rotational speed of the 125 tooth sprocket. Okay, so it's driver over driven times input speed. So it's 35 divided by 125 multiplied by 400, and that will get you the speed of the output sprocket. The output power of the motor, if the motor shaft produces a torque of 3.7 Newton meters. In your data booklet, there is a formula for the output power of 2 pi nt. Okay, 2 is 2, pi is 3.14, n is the number of revs per second, so you need to convert the answer here to the number of revs per second, and 3.7 is the torque. So that's how to calculate that. So it's 2 pi n. Pneumatic circuit is used in a drilling operation. So here is the circuit here. Describe, using appropriate terminology, how the pneumatic circuit operates. Right, and it's given you a starting point. Right. So when valve 1 is operated, right, so there's valve 1 there. Right, we'll assume that cylinder B is pressed on valve 7, so that means the air is coming down through valve 1 and it's already there waiting to get to valve 2. So valve 2 has then got to be pressed before pilot air gets round to valve 3, and this half of the piston will slide over, so connecting that port to there. So cylinder A will go positive, activating valve 6, which activates valve 4, making cylinder B go positive. So cylinder B has now gone positive. Now that activates valve 3 to make this happen here, so that is going there. That makes cylinder A go negative. Okay. Then when cylinder A goes negative, that activates valve 5. Valve 5 comes around and activates valve 4, making cylinder B go negative. Okay. The air will then come around here, and depending if these two are pressed, the process will keep going, but if they're released, the process will stop. Circuit diagram shows two forms of air, pilot and main air. Okay. Describe the difference between the two types. Main air is used to move the pistons about. The pilot air is moving valves. So the main air is for moving the pistons, the pilot air is to move the valves. For safety reasons, it was decided to slow the piston on cylinder B as it outstrokes. The piston should still instroke quickly. State the name of the pneumatic component which can be added to the circuit to slow the outstroke of the piston on cylinder B. Okay, it's a unidirectional restrictor. Okay. The unidirectional restrictor, the line, and there's two curves there, and a wee arrowhead at the top and a wee circle. Mark an X on the circuit where this component should be inserted. Now, so it's got to slow the outstroke of piston B. So there's piston B. It's got to go out slowly. So to make it go out, the air comes in here. Right? So this one is the exhaust air. You always restrict the exhaust air. So that the unidirectional restrictor will go on this line here. Right? The wee arrow thing pointing down the way. You restrict the exhaust air to avoid judder. To further improve the circuit, it was decided to include a time delay before cylinder A instrokes. Name the two components required to produce a pneumatic time delay. Okay, it's a unidirectional restrictor again, and a reservoir. Okay, the length of time delay can be varied by adjusting the restrictor or a bigger or smaller reservoir. State the name of the actuator on valve 8. Valve 8 has got a roller trip.